Okay, so we are solving systems by substitution today. Go ahead and throw your name on here. It is still first hour, and a system of equations is still a collection of two or more equations. I think that's on every note sheet this unit. I should put it on the test. The solution to our system is still the point that makes both of our equations true. Today, it's actually going to be easier to check your systems, and so I will show you once we get our first system done, I will show you how to check to make sure that your answer is correct. You can plug in both your x and your y. So, we today are doing the exact same steps 2 through 6 that we did on Friday, where we take an equation, we plug it into the other one, solve for one variable, plug that in to solve for our other variable, and write our solution as an ordered pair. What is new for today is that we are going to have to solve one of our equations for either x or y before we are able to plug it in. So we'll have to solve for either x or y. So moving down here, the first thing that we are going to do on this side of these notes is just practice solving for x or y. So you guys are going to have choices. A lot of times there is going to be an easier choice than others. So right here we have x minus 2y equals 1. Is my x closer to being by itself or my y? X. My x is closer to being by itself because there's not a coefficient with it. So you are going to want to look for the variable that is closest to being by itself and solve for that one. So if you want to write a note to yourself of what we are doing, on this one we are going to solve for x. When we do that, we are trying to get x equals by itself. So we need to get rid of that minus 2y. We can do that by adding 2y to both sides. So then we have x equals 1 plus 2y. Okay, my next one to the right there, negative 3x plus y equals 4. What's closer to being by itself? The y, because the x has a negative 3 with it. So we are closer to having y by itself, so we want to solve for y. We're trying to do the least amount of work possible. So we're going to add 3x to both sides. We will get y equals 4 plus 3x. You could write 4 plus 3x, you could write 3x plus 4. It doesn't matter. Everything's going to end up working the same. Okay. This one, neither x or y have a number with them. But which one's closer to being by itself? Y. What does x have with it? That negative. So because x has that negative, we want it to be by itself and positive. So it's going to be easier to solve for y in this one as well. Write that down if you need to know what we're doing. We're going to add x to both sides. So plus x plus x. So I get y equals negative 3 plus x. Okay. What's closer to being by itself in the last one? They're equal. It really doesn't matter in the last one. So it would be easier. It would be easy. Equal amounts of easy. Tied. I don't know what words I'm trying to say. It's an equal amount of difficulty to solve for x or y. Since we've already solved for y twice, let's solve for x. If you want to put a note to yourself if you're going to forget, you could say, but you could do y. So if I wanted to solve for x, I would get rid of the y. So I'm going to subtract y from both sides. X equals 17 minus y. On that one, you could put negative y plus 17 or 17 minus y. Order doesn't matter as long as the y is negative and the 17 is positive. Okay, so that is going to be the first step that you are going to have to do in all of these systems. You're going to have to identify a variable to solve for and solve for it. We always want to pick the variable that is going to be easiest to solve for. On your assignment, there's some like this where they're equally easy, but never like try to solve for that y by like, because you have to subtract x and then divide by -2. You don't want to do that. That's too much work. Okay, flip this over. We've got 2 full systems on the back because the only new thing that we are doing today is that first step. So, first thing that we're going to look at in our system, we've got 4x plus y equals -3, 2x plus 2y equals -12. What is closest to being by itself? X or y in the first or second equation? The y in the first one. So if you need to write a note to yourself that says, solve for y in number 1, you can. Because as we take notes, we always have like steps of what we're doing, but now we need to know why we're doing that and like what specifically. So I'm going to take my first equation, I'm going to rewrite it. 4x plus y equals -3. And I'm going to work on solving for y, which means I need to get rid of that 4x. I'm going to subtract 4x from both sides. So minus 4x minus 4x. I get y equals -3 minus 4x. Okay. Any questions about that? Okay. What I would do now is I would cross off your top equation. Don't scribble it out so much that you can't see it in case you need to go back. I'm just going to put a little X through it, okay? A little line through it. Because we now have a new version of that equation. So these are our 2 equations now. This guy and this guy. And from here, we're able to solve like normal. So our next step, the exact same thing we did Friday, we are going to take this y equals, we know y equals -3 minus 4x. Where are we able to plug that in to our other equation? For the y, because it is y equals. So it's going to go in this y right here. So I'm going to rewrite that. I've got 2x plus 2, open parentheses. I'm plugging in my new version of y, -3 minus 4x, close parentheses, and that is equal to -12. Okay. Any questions about plugging in? That's step 2. Is to substitute into an equation. Okay, and then step 3, distribute, combine like terms, solve, all that jazz. So we'll do, still have our 2x. We got 2 times -3, so that'll be -6. We've got 2 times -4x, that'll be -8x, equals -12. 2x minus 8x is -6x minus 6 equals -12. And then we will add 6 to both sides. Negative 6x equals negative 6. And finish solving by dividing both sides by negative 6. So I get x equals negative divided by negative is positive, and anything divided by itself is 1. So I get x equals 1. Any questions on that, which was steps 2 and 3? Okay, we are ready for steps 4 and 5 then, which is now that we've solved for x, we need to solve for y. We handy dandy have this equation that's y equals. So we're going to take that equation, the y equals negative 3 minus 4x, and we are plugging in the 1 we just got. We can plug that in for x. So now I've got y equals negative 3 minus 4 times 1. And then 4 times 1 is just 4. So I've got y equals negative 3 minus 4. And negative 3 minus 4 is negative 7. Y equals negative 7. Okay. And then the last thing that we always do is we write our answer as an ordered pair. So it's going to be 1, negative 7. Okay. Any questions about that first example? Okay. I will tell you right now, based on feedback from previous years, this is the most complicated thing we're doing this semester. Which makes sense because we're almost to the end of the unit. But elimination, people usually tend to like better. So just FYI, BTW, don't freak out. Do your best today, get help, but just know that this is one of the more complicated things we're doing. Before we do that last example, I do want to show you guys now how you would check these. So you would go back to your original equations, 4x plus y. So instead of 4x plus y, I would do 4 times 1, because I now know x equals 1, plus y is negative 7. Make sure I get negative 3 there, which I do. And then you have to do it in the other equation too. So you do 2 times 1 plus 2 times negative 7. Make sure I get negative 12, which I do. So you can always plug in x and y for x and y in both equations. Make sure it checks out. Hey, we got one more problem to do, and then we will spend the rest of class working. When we get done with this, I would encourage you to finish 3.4 before you try 3.5, and then we can help you with 3.5. Hey, 2x minus 3y equals 2. X plus 2y equals 5. What is closest to being by itself out of those 1, 2, 3, 4 variables? Which x? The x in the bottom of the equation. So I'm going to write a little note to ourselves of what we're doing. We're solving for x in number 2 this time. So I'm going to take my equation number 2. X plus 2y equals 15. And I'm going to solve for x. So I'm going to subtract 2y from both sides. I get x equals 15 minus 2y. Okay, I'm going to lightly cross that off. Boop. So now I've got 2 equations. I've got this 2x minus 3y equals 2. And I've got this x equals 15 minus 2y are my 2 equations I'm working with now. So I take my x equals equation, and I can plug it in for x in my other equation. This is the substitution that's happening. So I'm going to have 2 times, plugging in for x, 15 minus 2y. And I've got minus 3y equals 2. So that is step number 2, plugging in. Any questions right now? Okay, we can distribute combined like terms and solve. So 2 times 15 is 30. 2 times negative 2y is minus 4y. And I still have minus 3y equals 2. I can combine together my negative 4 and my negative 3 to be negative 7. So I've got 30 minus 7y equals 2. If you wanted to put negative 7y plus 30, you could. It's the same thing. I'm going to subtract 30 from both sides. I've got negative 7y equals negative 28. And then divide both sides by negative 7. I've got y equals negative divided by a negative, once again, is positive. 28 divided by 7 is 4. Okay, any questions right now? Okay, we're going to take our other equation then, the x equals equation, because what we still need to solve for is x. So I've got x equals 15 minus 2y. I can take that 4, plug it in for y, because I now know that y equals 4. So I will have x equals 15 minus 2 times 4. Two times 4 is 8. So now I've got x equals 15 minus 8. And then 15 minus 8 is 7. So I get x equals 7. We are going to always write our answer as an ordered pair. So this ordered pair is going to be 7, 4. Remember, your x always goes first. Okay. Any questions right now? Okay. I'm going to go ahead and stop this video then. Actually, I'm going to leave this on while I tell you guys this. Your assignment today has like a little riddle at the end of it where every problem has a letter and then the letter goes on the stupid riddle at the end. You still have to do all of the problems and have all of your work and have that correct. That's what we're checking. We put that riddle on 3.5 and then there's another riddle on 3.7. We do that so that if you're working and you get an answer, you can know if you're on the right track, if it's it's basically us giving you an answer bank. Okay?